Muchas gracias a ustedes por acompañarnos y muchísimas gracias a los ponentes que nos van a aportar sus conocimientos y su sabiduría. La mesa de hoy tiene como nombre Operativa y Mantenimiento, pero lo más importante es la segunda parte del título, que es en edificios más antiguos. Lo que nos van a presentar los distintos ponentes tiene que ver no con lo que entendemos por el FM, la parte posterior, la parte finalizada, cuando ha finalizado la obra, cuando ha finalizado el proyecto, sino con lo que pasa antes. En edificios existentes, en edificios históricos, el mantenimiento empieza antes que el BIM. Entonces, para no perder más tiempo, voy a dejar que cada uno de los ponentes se presente a sí mismo. El primero es Stephen Fay, por favor. Les dejo con él. Él mismo se presentará y explicará lo que está haciendo desde la Universidad de Canadá. Muchas gracias.
Thanks very much. This isn't actually my presentation. That's up on the... Well, I'm really very honored to be here today, and I think this is a very important event, and I wish we had some of these kinds of events in Canada. So first of all, my name is Stephen Fay. I'm a professor at the Israeli School of Architecture and Urbanism in Ottawa, Canada. And so where is this place? Well, that's Canada. And there's Ottawa, kind of in the just east of nowhere. We're located between Ottawa and, Toronto and Montreal. And Ottawa is it's the national capital of Canada, for those of you who didn't pass your geography lessons in school. So what is a Carleton Immersive Media Studio? It's a Carleton University Research Center. We're affiliated with the Israeli School of Architecture and Urbanism. We were established in 2002. The first director was my colleague Michael Gemtrude. He founded the lab in 2002, and then in 2007 he left the university, and I was given the gift of becoming the director of SIMS. And what I did at the time is I took the lab in quite a radical direction from the way Michael had been pursuing research, and I turned almost immediately to looking at building information modeling. My concern with the kind of modeling he was doing at the time, he was using Maya, Studio 3D Max, very high-end rendered models with absolutely no value beyond an animation. And it seemed to me almost criminal that you would spend $1 million to make a model and only have one function for it. So we started looking at building information modeling way back in 2007. I would invite you to visit our website. You can look at some of our projects. We have a very wide range of projects. I'm just going to talk about one specific project today, which I consider our most important project. Back in 2007, building information modeling was still in a bit of an infancy. In some parts of the world, it still is. And not only did we decide to take on building information modeling in its infancy, but we decided to apply it to heritage buildings and to existing buildings. And many people literally called me crazy in gatherings like this. So just a few terms sort of to contextualize what it is that we do. I try to avoid the rabid heritage conservation people, kind of radical chain myself to the building before I'll let them knock it down kind of idea. So we've modified some of the terms. Architectural conservation, we think of again, conservation to protect from harm or to protect something from destruction. And it doesn't have to be an old building. It can just be a significant building or a building you care about. Architectural rehabilitation, this is another area that we're very involved in. And again, to bring something back to good health, to restore it to a healthy life, right, a happy life. Heritage. Heritage, in our understanding of the term, are the cultural values associated with the built environment. So the buildings aren't heritage. It's the values that we attach to those buildings that are heritage. We have five streams of research: digitization, building information modeling, simulation, digitally assisted fabrication, and digitally assisted storytelling. And again, I'm not going to get into sort of the detail of that. Again, if you're interested, I would encourage you to have a look at our website. And the site is broken down into these 5 different categories. What I'm going to talk about today is some of the work that we're doing with Canada's Parliament building. And I say this is to my mind, the most significant project that we've been involved in. And this is the number one iconic complex of buildings in Canada. Every Canadian knows this complex of buildings. And I remember as a kid growing up in the western part of Canada, completely mesmerized that there were these fairy tale buildings that existed in my country. And so I feel very honored to be able to work on them some years later. So we began work on this complex in 2013, and it was a bit of a fluke, actually, our involvement. We had been doing a lot of laser scanning, again, in the context of existing buildings. And some of our collaborators within the federal government asked if we would write a report comparing photogrammetry to laser scanning as a way to capture an existing building in the context of the West Block. We wrote that report, and the project manager for the rehabilitation asked us if he could give us a retainer so that we could think of other ways to use the data. That doesn't happen very often in academia, where someone just offers you money to imagine. So we took that offer, and one of the suggestions that I made was a building information model. First question was, what is that? So I explained it to them. He said, are you some kind of consultant? This is the Director General. And I said, no, I'm a researcher. So he thought that was a good answer. And so he said, okay, go ahead, let's build this model. So initially, on your left-hand side, between 2013 and 15, we were tasked with building a model. And we were working in Revit, and I'll explain why that's the case. We were asked to build a model of the building prior to the rehabilitation. So the whole building was gutted. We were able to go in with some of our colleagues in the federal government, scan the inside and outside right down to the masonry construction. This is a load-bearing masonry building. When that was finished and the rehabilitation started, our contract technically ended, but the project manager, again, was very pleased with the quality of the work, and so he asked us to stay on and to model the existing building post-rehabilitation. So this is some of the point cloud data that we use to model the building. All of the building is modeled from terrestrial laser scanning. We've used no drawings, so it's all an as-found condition. For this building, there are about 1,200 individual scans using a Faro focus and the Leica P40 and C10. So this is the building before rehabilitation. You can see some of the construction materials. Again, in phase one, a very high level of detail and a very high level of information, because all of the finishes on the walls had been stripped off, so we could see the building was naked when we captured it. Again, just so you get a sense of some of the level of detail that we were able to achieve. Again, this is with Revit. And crazy engineer's dream, they tunneled down 4 stories in the courtyard of this 19th century building, solid limestone. They blasted it out and built additional space in that courtyard. So we're currently modeling that, a new construction. And again, this is some of the level of detail with a point cloud overlay. Second phase of the project came along in 2015. Again, we had finished the first phase of the West Block. Central Block was thinking of moving into a rehabilitation phase. So they came and had a look at the West Block. They liked what they saw. And there was a very forward-thinking project manager who decided that it was time for Canada's federal government to get into the building information modeling game. Canada has no national guidelines, and there is no interdepartmental committee within the federal government that's discussing any kind of national guidelines. We've been trying to bring them together. In Canada, Defence holds a lot of properties, and Public Services and Procurement Canada, who we're involved with, they also hold a lot of properties. And then there are Parks Canada, there are many departments, but there's no standard that's shared between them and no discussion that's happening, unfortunately. So in this project, the idea was that we would prepare a model that would be handed over to the architects and engineers to begin the rehabilitation process. So we had to work very fast. Again, we had to work in a commercial software that we knew the architects and engineers could use. The building is actually a hybrid of steel and load-bearing masonry. It was built in 1915 to 1917. The original center block burned down. in 1915. Again, the model is constructed from point cloud data and from historical drawings. And this is the quality of the drawings that we were working with. There are roughly 12,000 pieces of individual steel. Each has been modeled uniquely and has a unique identifier. And each piece of steel is linked back to the drawing that it was taken from and to the steel catalog that the section was taken from. So it's a bit like a footnote, if you will. So the model's broken down into 5 distinct component models. So there's the as-found structural, the as-found shell, that's the load-bearing masonry, the roof. We went through 5 different protocols for modeling the complexity of this kind of roof. As-found interiors, again, all based on scan data, and the slabs and circulation model. And then the federated model, you can see it in the 5 components. Again, very high level of detail for most of the areas, particularly the special areas like the House of Commons and the Senate, this sort of ceremonial areas, if you will. But very low level of information. And that's because there was no exploration as to the actual fabric of the building, and we didn't want to put in any information that we hadn't verified. So this model has now been handed over to the architects and engineers. I can't tell you who they are because it's still secret. But they've gone through the model, they've checked it using Celebri, and they're satisfied with the quality of the model. In fact, they said it's the best as-found model they've seen. So I'm very proud of that. So this summer we've been asked to address the East Block, which is the building just at the bottom of this of the complex here. It's one of the original buildings, again, dates from the late 19th century, 1875, 1876, I think was the last edition. This building was captured by our colleagues at Public Works, Heritage Conservation Services. They captured the entire exterior facade and interior of the courtyard using photogrammetry. As a result, the point cloud is very, very high quality, so it's very nice to model from. This is the kind of detail that we're working toward. Some of you are probably looking at this thing, that why go to that level of detail? Because we're a research center, so we can. And one of our sort of call to arms is too much is never enough. And so we just keep trying to push the level of detail, the level of information. And again, I'm going to come back to why that is at the end of the presentation. We also modeled the underground connections between the East Block and the Center Block. And again, this project will be continuing for the next 3 years. We'll also be doing an Energy Plus model derived from the building information model. So in the West Block, it was really just a record model. Center Block was a model that was going to be used in the rehabilitation process. And the East Block is going to be Public Works, this area of government, this agency of the government. It'll be their most developed building information model that they've taken on. So there will be it'll be ready for the consultants, but also we'll have an energy analysis, and we're also modeling all of the mechanical equipment. So as a result of this, we now have if you will, a campus model, and this is the plan. So again, on your left, the West Block, the Center Block. On the right, the West Block. You see that kind of round building in the back? That's the Library of Parliament. It's the 5th building, 5th element. And we've just been given the nod to record it. We haven't been given the nod to model it yet, but it's an absolutely beautiful Victorian building. These are some of the data sets that we've been using. So GIS, Civil 3D, as well as our own scan data. And we brought that all together just to verify the information, and have built a topographic model. Now, as part of the campus model, we've developed detailed protocols for all novel modeling procedures that we've used. So if there's a YouTube video on it, then we don't do a protocol. But if it's something that we've developed on our own, as I mentioned, we did 5 iterations for a roof, for modeling those kinds of the complexity and the deformations in that 19th century roof. We've written it out and in a step-by-step protocol. So that means that there's consistent protocols all across all 3 of the buildings. as we improve the modeling process, we go back to the previous building and remodel it. So the whole campus is modeled to the same level of detail and following the same protocols. And of course, this is also very valuable when handing the model over to the architects and engineers. We also came up with a verification system for level of accuracy. So anything that's in green has been verified on both sides to point cloud. Anything in yellow has been verified maybe on one side to point cloud, or in the case of some of the steel, it's been covered with a fire retardant. So we can't say with absolute certainty that the building is as we've modeled it. Red is there is no point cloud data available, so it's modeled from some secondary source, and the purple means you need to go on site and have a look at that. We have a problem, and that was a kind of an internal check that we developed. But again, we've handed all this over to the consultants, and they seem quite happy. All of the point clouds, so actually all of our targets are tied into a known georeferenced survey system. So as a result, all of the point clouds are georeferenced. As a result, the BIMs, I suppose, are georeferenced to real world coordinates. Now, anticipated uses. Obviously, facilities management and operations. Now, this is something that when I mention this to most of the people in the federal government right now, there's kind of a blank face. Because for them, it's not their responsibility, the people that we're working with, it's not their responsibility to worry about facilities management. They need to get these rehabilitation projects done. So they say, you want to worry about that, you go talk to this person over here. And you all know what happens when you go talk to that person over there. Security is another area that the RCMP, the Royal Canadian Mounted Police, have identified as a potential value in the model. Finally, storytelling. And I just wanted to touch on this briefly. Again, the level of detail. And in many buildings, perhaps, the notion of storytelling or heritage might not be so important. But for a building like the Centre Block, which is, again, the iconic symbol of Canada, as the architectural symbol of Canada, that building is going to be closed for 10 to 15 years. So they receive about 1 million visitors a year at the Centre Block. There'll be a whole generation of kids who won't have access to that building. So they've asked us to come up with ways to leverage the campus model, leverage the model of the Centre Block in order to tell Canadians the story of what happened at the Centre Block, how did it come to be, what's happening now, and what is it going to be in the future. So we've developed a number of applications. Right now there's a virtual reality experience right across from the Centre Block that, again, leverages the models and the point clouds that we've already developed and the 360 photospheres that we've developed to give color value to the point clouds. And now we're working on this website, which will be launched July 1st, which is Canada Day. And this is going to tell one story every month for the next 5 years about the Parliament buildings. And the Assistant Deputy Minister is really pumped up about this project and is suggesting we could make it last 10 years. So that should take me well into my retirement. Thank you. I'll be looking forward to any questions you might have.
Muchísimas gracias por la brevedad. Nuestro siguiente ponente es Tero, viene de Finlandia, de la empresa Granlund, y nuevamente dejaré el que se presente, que lo hará muchísimo mejor.
So, hello everybody. My name is Tero Järvinen. I come from Finland. Ground is our company, and I'm a technology director at the Innovation and Development Department. So I have too many slides, sorry, I will go really fast, some slides, and for example our mandatory company slides, what we are, this is quite fast. I already shared this presentation to LinkedIn and Twitter and so on, so you can find it from SlideShare if you want to see. What Granlund is doing, we are doing mechanical designing and consultants. Mainly these areas, but not in a residential area. Hospitals are quite big in our turnover, and data centers are rising all the time because of Finnish weather and electrical conditions and all these things. These kind of projects we are doing right now, there are all hospitals, and this is the amount of people what we have. HVAC and electrical designing is the main part of our business. This mission critical means data centers, and as I said, I'm coming from innovation and development department. We have about 11 or 10 people working only in the innovation and developments, not at project work at all. And also we are a software company, so we have grounded manager, which is for facility management, and grounded designer, which is for designing and construction phase. Designer is a mechanical equipment device schedule software, and manager is like a real FM software. But manager does not have any connections to building information models. And that's why I have that presentation, that maybe we could have that kind of connections. Yes, we are making money, and we are spending money also. So this is our investment in the last year. So in a grounded group, this 750 people, it's a 7% of turnover going not to me, but in our department. And we have lots of involvement in EU projects and different kind of research projects also. We have a strategy, what we are going to do. So now we are in a phase that we are gathering information, we are making slide analyzing of information, but we want to create reporting facility, we want to take forecasts how facility is behaving, and we want to have a possibility to learn. The facility will learn itself when it has these first steps ready. So we are not thinking just the facility, we are thinking the people inside of the facility. So we want to be in a situation that there is a user and a facility which are communicating each other. When I walk out of here, the facility knows where I'm going. I will accept that. Every people, they do not accept that kind of thing that you are tracked. But it's something that we want to research more. Okay, then to the point. Concept of our BIM to FM. So this is our working name, building information models in use in FM or whatever. BIM to FM is our word when we are talking about these things. This is something that we need to understand quite well when we are talking about models. So in the lower level here is a designing. So we are designing buildings, and then general contractors are making the buildings. And this part is lots of information, lots of information storage, and lots of loose connections that we have lots of information, but they are not connected at all. So when we are putting these kind of as-built models, that we have the grounding okay when we have as-built models, we need to enrich the information for if we want to use the information in technical operations. But where we are focusing, where is grounded manager is now, it's a software for property portfolio management. So people who are interested about euros, designers are maybe interested about kilowatt hours. So we need to go to the money. And nowadays, these decisions in the building in this area is made like a rule of thumb, or that some other building is behaving also like that. So I will write something similar what that other building is doing. So big decisions are made just by knowing the good professionality what the people have in that level. So we want to give the information to them to have decisions make by knowledge. And there is a business use cases, and somewhere here middle is information models to facility management. I don't know where it is, but it's somewhere there for my opinion. And we have searched about 5 years that red line, and we are still searching. But now we are quite far for searching, and we maybe know what we're going to do in the next year or next two before we have the software. So these are like my thesis, the BIM to FM. Okay. So information what we have, it has to be standardized. it has to be machine readable. In Finland, we are using IFC heavily. In every project, we create IFCs. For example, design and construction project, we do not care what software other companies are using. Everybody is providing IFC to the project bank. Everybody is downloading the IFCs and putting together in their own company and looking at the compiled federated models. So, but the content is not standardized. When we are talking about different architectural companies or different structural designers, we have different kind of content all the time. So it's like a learning in every project, and that's a hell. But in facility management, we need standardized information. There are too much information in our models, so information has to be prioritized. So building owner or us as a consultant need to tell them what is important in your building, what kind of network is something that you want to care of. And we cannot update all the information that we have because the information amount is so huge. So prioritize it. It has to be in a cloud, so it has to be available all the time, information. Information is not transferred, it's linked. And this is a quite complicated task to fulfill. But if we transfer the information to software, we have always old and wrong information and some other systems. So there has to be connections. It has to be updated. There are, in the morning, a term digital twin was also in other session room, and that's true. And I believe in that idea that we have like a digital building and a real building, and we have to update both. So maintenance is going real building and updating is going to the digital building. And we can simulate the digital building to next week and so on. So we are like playing on the digital building, and that is steering the real building. This is something that we want to be involved. We do not have yet. FM operations, they will be different. So we need to change. That's the fact. This means that what Stephen was saying also, that in Finland, construction organizations are like an own silo, and FM organizations are own other silo. Even they are working in the same company, there are different people and different departments, and they do not understand each other. And what we need to create is like a bridge of these organizations. And there has to be somebody telling when we start designing how building owner wants to use models in facility management, and it's done by FM coordinator. So this kind of role is new, at least in Finland. He has to understand models, and he has to understand facility management also, and use cases what they want to take there. So a little bit of complexity of the mechanical models. This is a hospital, renovated hospital in Helsinki. Was it a 17th story or high or something like that? And this is the amount of objects in that model. So we can see that we have almost 500,000 objects in a mechanical model, and comparing to architectural model, it's something like 25,000. So complexity in mechanical models are really huge. So that's why we need prioritization. We need to have about 50,000 objects or something that we can update. There is no use to put models inside of the facility management software if you are not willing to update the information. This is what is important. So like decision making, you need to decide which is important. If I'm in the operating theater, I hope mechanical designer has connect the electricity on the spare power also. But if in office, if the heating pump is run down, is broken, there is no hurry. I have 2 day time to fix it. So we need to make decisions. Facility management information is not inside of the graphical models. As I said, we are using IFC heavily. IFC has lots of information, but we cannot update that information without opening native software, for example. For example, Revit or or how. That's how. Facility managers cannot use Revit. They cannot use building information model softwares. That's a fact, because they are not engineers. They are not like they do not have mindset to understand what is building information model. That's why we need to simplify the information and create environment where they have like multiple different use cases, like apps to do something which is really simplified. And that's how we need links to databases. In the mechanical world, all the important information is on the device schedules. All the central units, all the filters, all this kind of information lies on the different database. It's not inside of the Revit model or IFC model. There is object. There is like a GUID what we can use in a graphical model, but the information is on a different database, and that's we need connect. And when we have these two information sources, we have like all to update the mechanical models. How I will skip this. This means that how to update how to create as-built models. So in designing phase, we are creating a device schedule using Ground Designer. It's a cloud-based software. We make approval packages and give login names and password to contractor. Contractor sees what we have put into our database, and they suggest some other device because it's cheaper. And that's normal in Nordic countries, that contractors change everything what the designer has designed. Strange situation, but that's how it is. And then designer makes approval, reject or accept, and so on. And the end result is that through this process we have as-built information in our database without extra work, because the approval has to be done. Where we are now in IFC in Finland, so for my opinion, the construction phase, designing phase, is going quite good. So we know what to do. There's a little bit debate all the time, the accuracy of our model. I could say that our accuracy of a mechanical model is 5 to 2 centimeters, so 0 to 5 centimeters. And that should be enough for contractor, but some contractor does not accept that kind of accuracy. We are designers. We are not making models to make the installations. So that's why we want to have that possibility to have a little tolerance in our models, because also the huge amount of information and graphical pipes and ducts what we have in models. So what we are learning is now, when we are going to facility management, that we need to standardize the information. So we are dealing with IFCs, and we are a little bit tweaking IFCs information and device schedule information that should be standardized. And after we have that done, we can start using models in facility management. But when you are putting information to software, this has to be standardized, because we cannot make prototypes for every building. It has to be, from software side, it has to look same, depending on the buildings. Role-based information is the keyword also. So when we have a central place, like not one place but multiple places where we have information, it depends your role what you can see. For example, designer creates device schedules. He is interested about pumps and air handling units. Supervisor, or maybe not interested detail level, but he wants to know what is accept or reject, what kind of equipments there are. Building owner wants to see something else, but the main thing is that the information is scattered in a cloud, and it's linked, and people are looking the information through different roles. So this is what we are now doing. We have, for example, a Revit model, and we have put that to the IFC, and we have some information coming IFC. So we are not using all the information because it's meaningless to facility management. We have device schedule information, building automation system information, or IoT sensor information, And if I click something, I can see a whole bunch of information. Problem is now that the same information is in other places also. So how to decide what is the correct information? That's the problem nowadays. And at a technical point of view, this is what we are believing. So I will show rapidly this center part up to a couple of minutes. But we are creating documented APIs. So open data is really great, but facility management information cannot be open. It can be standardized, it can be documented, but we cannot deliver information from building to all of the world without authentications and these kind of things. So basically, we are creating like a platform where we could, it's a bridge where we could have, for example, IoT sensor information shown here, and we have space information from facility management software, and we link this to information, and when I click the space, I can see the temperature of that space. That's like a basic thing. And also building automation systems have quite poor APIs, but we could connect to them also. In Finland, we can connect almost every manufacturer building automation system and gather information and show information that you understand it. All the information is inside of the building automation system, but it's in the format that only technician can understand what there is. We want to bring one level more. So this is something that I do not understand, but this is something that I believe. So this is like a semantic web linked data. We have a research project, Drumbeat, going on in Finland. And this means that all different software parts are linked together somehow magically, automatically, I don't know. But the professors said me that, okay, it could be like that. I'm a believer. And also Tekla is there. So there is maybe some black box where we put all the information and suddenly we have correct information, I don't know. But I can see that our softwares are here like 1.there and 1.there and some other software is here. So we want to connect to as many softwares as possible to have the correct information from multiple sources. So I will now show this demo. So this is from Senat Properties building Finnish National Museum, and this is a prototype. This is not a software. This is straight from our developer's desktop, and he hates when I show it because he do not know all the time is it working. But all this information is coming from IoT sensor of these spaces. This information is coming from open source, open data from city of Helsinki. And here you can see temperatures, you can change the floor. If I want to see a little bit more, I can see like a trend. And all this information is already inside of that building, but it's on multiple locations that the people inside of this museum does not have a view, the information which is collected on one place. And there's also relative humidity sensors and so on. Next phase is that because there are like, what is the correct word? Vitrines, you know, where are inside is something which is inside of the museum. So we will have like equipment also inside of the spaces, so they can really fast see if everything is okay. In the morning when they're going to work, everything's green, great, let's go to work. If there's some red or something else, there may be some problems. Yeah, so I hope that was my presentation. I hope I'm in time. Thank you.
Bueno, pues muy bien, vamos ganando minutos. El tercer ponente, Alberto. Muchas gracias, te presentas tú mismo.
Hola, buenas tardes. Soy Alberto Armisen, el promotor de este proyecto que se llama Petrovin. Alguno igual ya ha oído hablar de él, porque en las redes sociales somos bastante pesados. Y bueno, lo que pretendemos con Petrovin... Vale. Lo que pretendemos con PetroBIM es llevar el BIM al patrimonio. Petro viene de piedra, no de petróleo, como mucha gente me ha dicho, y lo hacemos de una forma peculiar, y es que no trabajamos con estándares. PetroBIM trabaja con edificios históricos de siglos o de muchos años, donde pues todo lo que le envuelve y lo que lo conforma pues está constituido por piedras de cantería, etcétera, etcétera. Bien, para empezar, lo que vimos, un equipo de técnicos, científicos, universidad, catedráticos, ingenieros, arquitectos que están detrás de este proyecto, es que en el mundo del patrimonio hay un cierto desorden, ¿no? Es un cierto desorden, al igual que ha venido sucediendo o que viene sucediendo en el mundo de la obra nueva, ¿no? Para ello concebimos una plataforma virtual, entendiendo como virtual porque trabajamos con edificios virtuales para proyectos técnicos de estudio, gestión y difusión del patrimonio. Y lo de difusión, aunque no está subrayado aquí, lo subrayamos, de un patrimonio histórico en entornos BIM, ¿no? Esto es lo que nosotros entendemos como HBIM. Mucha gente utiliza la H de Heritage con el fin de aproximarse lo más posible al patrimonio, pero no siempre se consigue, porque trabajar con ladrillos estándares en un edificio que en realidad lo que tiene en vez de un ladrillo es una arenisca del siglo XIV, pues tiene poco que ver, ¿no? Bueno, una necesidad que era poner orden al desorden. Los geólogos, petrólogos, arqueólogos, arquitectos, técnicos que conforman un proyecto o que trabajan en un proyecto de restauración o que están al amparo de un plan director, se encuentran de esta manera. Se encuentran muchas veces en una forma caótica. ¿Por qué? Pues porque cada uno está en su gabinete y cuando tienen que vertir la información al responsable del proyecto o del plan director, pues se tropiezan unos van con planos en papel, otros van con dibujos con colores a mano alzada. La tecnología brilla por su ausencia en algunos casos, ¿no? Y entonces decidimos crear una herramienta sobre la que se pueda proyectar y capaz de albergar toda esa documentación que los técnicos han ido gestionando en el transcurso de los siglos en muchos casos. Luego vamos a ver un caso muy que nos va a hacer reflexionar mucho. Y toda esta documentación está asociada a la conservación y al mantenimiento de un monumento histórico y bien cultural de manera atractiva e intuitiva. ¿Por qué lo hemos considerado así? Bueno, pues porque hoy siempre que se interviene sobre un bien de interés cultural, la mayoría, dicho siempre no, pero la mayoría de las veces se hace de forma reactiva. O sea, llegamos cuando ya ha habido el colapso de la cubierta, llegamos cuando ya nos han comido los hongos hasta 1,5 metros, llegamos cuando las humedades han derrumbado parte de cierto muro. Bueno, pues lo que hemos tratado es de hacer que esta iniciativa permita que todos intervengan, arquitectos, aparejadores, arqueólogos, etcétera, y se comuniquen con los protocolos válidos, ¿no? IFC, BCF, DXF, etcétera. Nosotros trabajamos desde la entrada hasta la salida con archivos que todo el mundo conoce y que para nadie resulta novedoso. Y cómo no, de forma colaborativa, que es, digamos, el sentir o el padecer o el karma de BIM, ¿no? Convirtiendo esto en una herramienta integradora y eficaz, aumentando la productividad. Si nos damos cuenta, el modelo virtual es sobre el cual gira toda la gestión, toda la información. Esto no olvidemos, luego lo vamos a ver, que esto es un repositorio de información que puede ser consultada desde un nivel turístico hasta un nivel muy científico. Generamos por ello una conservación efectiva y preventiva, tanto en cuanto PetroBIM nos permite alimentar el modelo de información que genere alertas de mantenimiento, y esto lleva ahorro y servicio de costes en los planes directores, ¿no? O en los proyectos. Normalmente la tecnología se viene utilizando, los planes directores vienen utilizando algo de tecnología, pero aún así es muy escasa para poder disponer de unas BIL real. Se trata de la metodología BIM aplicada a los proyectos de conservación y restauración del patrimonio histórico. Integramos toda la información en la nube para la gestión de proyectos sólidos y robustos en un entorno visual, navegable y vivo. Si veis esta imagen, luego pues trabajaré sobre el modelo real. Esta imagen le hemos generado una serie de consultas, ¿no? Voy a poner las gafas porque no veo. Bueno, si os dais cuenta, hemos seleccionado la pestaña de elementos constructivos. Esta es una pestaña, o un módulo, que conforma el número de módulos que exigen en España todas las intervenciones que se aplican a bienes de interés cultural y a planes directores recogidos dentro de los planes nacionales. Por lo tanto, aquí nadie se ha inventado nada. Aquí hemos hecho una consulta, elementos constructivos, y hemos seleccionado que nos muestre los escultóricos y toda la fábrica que hay y la ornamentación. Automáticamente, por una paleta de colores, nos muestra esa información en distintos tonos, y a la derecha pues podemos ver el número de elementos, la superficie que ocupa y su volumen, ¿no? La arquitectura de la herramienta, partimos de planos. Este modelo que habéis visto se realizó a mano alzada. Es un trabajo que hizo un arquitecto asturiano hace un montón de años, y que pues la documentación gráfica que existía era su documentación a mano alzada, que es la que veis ahí arriba, que luego evidentemente se llevó a una planimetría DWG, a partir de la cual nosotros levantamos el modelo en Google SketchUp, y luego ahí late nuestra tecnología. Exportamos un FBX, lo metemos en el corazón Petrobin, el corazón Petrobin late, vincula toda la geometría de los sillares con todos los identificadores con toda la información vinculada a ese identificador, y como hemos visto antes, nos muestra la información consultada. Accedemos a esta plataforma gestionándola por niveles de permiso según usuario, ¿no? Podemos filtrar los oficios y los gremios dependiendo de la categoría o dependiendo del nivel de acceso que se pretenda. Nosotros estructuramos y establecemos el nivel de detalle dependiendo de el LOD que se aplica en patrimonio depende de la necesidad de la intervención. Aquí, como podéis ver, pues es una malla que recoge un ornamento en una especie, un ornamento en la Catedral de Segovia, y este ornamento pues tiene una triangulación muy grande, porque podemos acceder o debemos acceder para tratarlo hasta ese nivel de información. Sin embargo, en esta otra imagen que hay abajo, que es la Catedral de Palma de Mallorca, aquí solamente se ha trabajado a nivel de sillar con una información solo arquitectónica, donde no nos ha importado para nada la parte del retablo, ni los ornamentos, ni nada que en este caso al arquitecto le importase, ¿no? La descripción de la herramienta, se accede a través de un código de acceso. Accedemos a una carpeta donde figuran o están todos nuestros proyectos, y digamos que un poco la presentación nos permite ver los módulos de trabajo que están en la izquierda, esos 8 módulos donde tenemos las intervenciones, análisis de las patologías, las humedades, la sensórica, el mantenimiento, etcétera. Luego la visualización del modelo, que nos mostrará toda la información, incluso cruzada, que hemos previamente consultado antes. Y luego nos aparece esa leyenda en la que visualizamos pues la consulta generada. Si os dais cuenta, a la izquierda del todo, hay una serie de herramientas que llamamos un poco CAD, que nos permiten pues hacer mediciones sobre el modelo, etcétera, etcétera. Estas son distintas herramientas que nos permiten hacer secciones a distinta altura, para comprobar distintas secuencias o fases, etcétera. En la parte de proyectos tenemos las pestañas de información general, la parte de modelo, la parte de usuarios y en qué régimen acceden, y luego la parte de documentación. Esa parte de documentación genera una serie de subcarpetas que va enriqueciendo el modelo, de tal manera que la herencia que se deja a quien precede al que lleva el mantenimiento de este modelo está actualizada. No es como ahora, que en la Catedral de Segovia la empresa que restauró una de las cubiertas, un tramo de la cubierta, 10 años después le han vuelto a pedir que restaure exactamente lo mismo, a la misma empresa. Y la empresa, pues fue honesta y dijo, ¿pero por qué me lo volvéis a pedir? Y dijo, pero esto está hecho. Pues es así. A veces este mundo del patrimonio se encuentra un poco despistado, ¿no? Y hemos intentado enfocarlo y reorientarlo. Bueno, aquí podemos encontrar, esta es la capilla que os comentaba, del Sagrado Corazón. Aquí podemos acceder a un nivel de selección filtrando lo que nos interesa trabajar. En este caso, pues vamos a las nervaduras, a los apliques que existen en las nervaduras. También conservamos todo lo que es la parte de vidriera, porque queremos intervenir directamente sobre eso. El resto nos molesta. Es una manera de poder aislarlo y trabajar cómodamente. Si os dais cuenta, esto forma parte de una capilla completa, que es una de las 26 capillas que tiene la Catedral de Palma. Aquí podemos individualizar el elemento para que los restauradores puedan intervenir y trabajar directamente sobre el retablo, y siempre bajo una metodología BIM, porque trabajamos siempre sobre un modelo, trabajamos siempre de forma colaborativa, trabajamos siempre sobre unos protocolos de intercambio válidos y trabajamos siempre sobre una usabilidad compatible. Quiere decir esto que obedece a los cánones que prescribe o va a prescribir la Administración cuando exija el BIM en sus pliegos de condiciones, ¿no? El otro día Íñigo de la Serna, el ministro, hablaba de que iba a destinar el 1,5%, son 430 millones de euros. Esperemos que sea verdad, independientemente de que el Ministerio de que Cultura y Deporte pues destine otro tanto, el Instituto de Patrimonio destine otro tanto. Creemos que además, como el 2018 es el año europeo del patrimonio, pues va a haber mucho trabajo en esta dirección. Se abre una línea de negocio grande, gracias a que aquí intervienen muchos técnicos que ahora mismo pues se encuentran con poco trabajo. Bien, es cierto que no cabe duda que como estamos tratando de evangelizar tanto en la sala grande de la que venimos como aquí, pues ese cambio de filosofía, ese cambio de chip es determinante, es clave. Este es un ejemplo que os iba a comentar. Esta Santa Cristina, que está en la cuenca minera, en Pola de Lena, está levantada sobre una loma, es preciosa, es un prerrománico asturiano. Y aquí hay un análisis patológico resultante. Aquí tenemos las plumas de humedad. Estoy haciendo un repaso un poquito largo, más que largo, estoy haciendo un repaso rápido porque la herramienta entra muy en profundidad y tengo el tiempo que tengo. Entonces, procuro más o menos que de un vistazo os podáis hacer una idea de hasta dónde se puede llegar, ¿no? Y esto es lo que os quería contar antes. Aquí donde lo veis, este edificio, se ha hecho una selección donde las pestañas que hemos clicado muestran distintas fases constructivas. Y efectivamente aquí hay una fase constructiva que es morada, otra verde, que es un recrecido del edificio, otra rosa. ¿Esto a qué responde? Si nos seleccionamos en la parte verde, esto responde a una reposición que hubo como consecuencia de una deflagración en la guerra en el 37 en la República, y es la época de Ferran, donde estos sillares, muchos de ellos se fueron a las casas de los habitantes del pueblo porque se las llevaron para hacer sus cuadras, etcétera, y otras proceden de unas canteras que hay por allí. Y entonces tenemos la posibilidad de aislar y trabajar directamente con esos elementos. Esto a nivel histórico, a nivel cultural, es una información bestial. ¿Por qué bestial? Porque sin darnos, sin ir más lejos que una mera circulación por el monumento, ya hemos recorrido unas fases constructivas, ya hemos visto el tipo de patologías, podemos trabajar sobre la fase afectada de manera individualizada. Esto es un BIM en toda regla, ¿no? Es un HBIM, porque en Petrobim creemos que nosotros verdaderamente nos merecemos la H. No queremos desmerecer a nadie, pero que no todo el mundo sea Project Manager, o que no todo el mundo sea BIM Manager, que no todo el mundo... que las cosas son como son, y entendemos que nos ha costado mucho completar esta herramienta para que sea un HBIM. ¿Qué conseguimos? Desde luego tenemos un ASPIL vivo que se retroalimenta cuando decimos vivo, que es sensible de actualizaciones posteriores. Y luego hay una de las cosas sobre la que más incido, y es que cuando hemos trabajado a este nivel de información, con un código de acceso para que trabajen nuestros técnicos, los que trabajan en nuestro entorno, ese código de acceso con un formato de solo lectura lo podemos poner en cualquier universidad del mundo, de tal forma que ven cómo en España, que es uno de los 3 países más importantes del mundo en patrimonio, trabaja sus monumentos. Y en las universidades o en las facultades o en los laboratorios verán, cuando cliquen en un sillar, qué porosidad, qué grado de alteración, qué salinidad, qué parámetros hemos utilizado o hemos dado para dar a conocer o para conservar este bien que está ahí para verlo, ¿no? Y entonces, ¿esto qué hace? Bueno, un efecto rebote, que al final pues se sensibilice la gente y quiera venir a verlo, ¿no? Que al final pues es un poco lo que perseguimos. Esto a nivel político es una medalla, esto es el dinero trasladado al impacto, ¿no? Bueno, luego tenemos el capítulo de intervención, en donde pues tenemos una pequeña base de datos con la capacidad de generar pequeñas estimaciones presupuestarias para que nosotros podamos hacer un pequeño presupuesto. Toda la base de datos que está aquí generada, toda la alimentación está regida y está sujeta al Ultimas y Coremans, que es la publicación por la que se está velando, por la que el instituto, lo diré, el ICOMOS, efectivamente, sobre la que el ICOMOS ha establecido los criterios y las bases de datos para que podamos alimentar esto con los términos adecuados. Bien, esto es una de las partidas, uno de los módulos que trabaja el mantenimiento. Aquí, si os dais cuenta, tenemos pues la limpieza de la pátina biológica, que está en la parte próxima al suelo. La frecuencia debe de ser semestral, la fecha de inicio del plan, el 1 de enero del 2016, y el email que va a recibir cultura@cultura.es, pues es quien llevará la alerta para que se pueda llevar a cabo esa acción. Y luego, además, este Jesús Hidalgo, que es el responsable de patrimonio, pues tendrá que darle al OK, como diciendo que se ha hecho esa intervención. No quiero terminar sin antes enseñaros, si es que puedo, que creo que puedo, y si tengo tiempo, José, un minuto, madre mía. Parece que estoy tocándolo. Y ahora otra vez. Nervios. Bueno, trabaja en la nube, accedemos a la nube, se actualiza en la nube, podemos estar trabajando en casa sin conexión y se actualiza en el momento en el que haya conexión. No sé cómo andamos de wifi aquí. Bien, este es el modelo. Si veis, con 4.700 elementos podemos hacerle una serie de consultas, como que la visualización de este sillar, y aquí nos aparecen sus características, ¿no? Piedra roca sedimentaria, color blanco, densidad, etcétera, etcétera. Podemos editar la información de este sillar a nivel de campaña, información básica, podemos aumentar e enriquecer los modelos. Y luego hay una parte, pues que es de sensórica, que antes estaban hablando a la hora de llevar el facility, que algunos ya conoceréis este sistema de monitorización, que es de la Fundación Santa María la Real y Telefónica, que luego no se diga que no trabajamos con nuestras empresas españolas. Y bueno, pues quería mostraros cómo somos capaces de mover este modelo, que no son más de 100 metros cuadrados, y otros modelos, pues como la Universidad Laboral, que está en Gijón, que tiene 300.000 metros cuadrados de superficie, y que solamente os la voy a enseñar sin entrar a más detalles, porque José me está mirando con cara de voy a acabar contigo. Si es que la tengo aquí a tiro. Bueno, pues esto era un poco lo que os quería enseñar, que no hay límites de tamaño, no hay límite para poder llevar un proyecto adelante y que, bueno, en patrimonio España tiene que dar una lección a nivel mundial. Creemos, porque quienes estamos o formamos parte de la familia Building Smart, nosotros nos hemos incorporado hace poquito, creemos que podemos dar una lección no solo a nivel europeo, sino a nivel mundial, porque sabemos muy bien lo que es trabajar el patrimonio. Y creemos de verdad que somos el primer país que trabaja HBIM de verdad. Nada más. Muchas gracias.
Disponemos de 4 minutos para poder responder preguntas. Si alguien tiene alguna consulta concreta para alguno de los ponentes, por favor. Ángel.
Sí, para Alberto. A mí me gustaría saber si también incluís documentación histórica dentro de...
Totalmente, es clave, es determinante, porque la documentación histórica forma parte del patrimonio, es inherente. Y de hecho, cuando hablaba de ese código de acceso en las universidades, de lo que se trata es de que se enteren de la historia, ¿no? Esa deflagración es historia, eso no puede... Claro, claro, por eso aquí hay historiadores que velan porque efectivamente la información que se aporte también sea una documentación gráfica. Decía el director del plan director de la Catedral de Oviedo, Jorge Evia, decía, Alberto, voy a agotar el presupuesto y quiero, por favor, que Petrobin sea mi colofón. ¿Por qué? Porque después de 20 años dirigiendo ese proyecto, tengo todo el repositorio histórico de la información de la Catedral, desde las distintas guerras que han pasado por ella hasta pues todo ese archivo histórico, bueno, pues las intervenciones que se han hecho en el Santo Sudario, que tiene ay, por Dios, ¿cómo está el Santo Sudario en Oviedo? ¿Cómo se llama? Bueno, no me sale. Bien, pues toda sea una historia, para él sería, y será, si todo sigue en marcha, pues será... Y ahora estamos trabajando, bueno, pues con catedrales, estamos con la de Burgos haciendo alguna cosa, estamos con la de Palma de Mallorca, aquí en Barcelona pues estamos empezando, ya que el laboratorio que está analizando mucho de las rocas de la Sagrada Familia es parte de este proyecto, que es GEA, pues estamos, bueno, tentando, ¿no? Lo que pasa es que, bueno, son proyectos de envergadura, etcétera, y hay que estructurarlos bien. Así que... está. Muchas gracias.
Any questions for Tero or Stefan? One? Tero, one question. Is IFC 5 format enough for facility management? Do you need to add new PSETs or?
Yeah, for my opinion, IFC is enough because basically I'm not sure now what I'm going to say, but first IFC is transfer format. So I want to create IFC in some modern software, put that information in the database and a graphical presentation in separate locations. And then I have link. And when I'm updating and changing information, I'm changing information in the database all the time. So if I want to change the pump type or change some information, I do not need to open 3D code. It just goes straight to the database that I have up for that database. So that's So it's a silly. Wow. Well, I speak really loud. So we want to transfer IFC information and then get rid of IFC information, but we have that same information elsewhere, which will go further. That is what we are doing in facility management then.
Yeah, but do you need to add any special PSIDs in order to move that information?
Sorry, special?
PSIDs.
Yeah, that's a standardization part. So we need the standardization that we have correct information what we want. And the information has to be in depending use cases. So that's why we need to know how building owner wants to use our models. So we need to ask that information in really early phases of the project, because everything is not possible. You cannot do it. You need to know how to make models, where to put information, and so on. And after that, we can use the info.
Okay, thank you. One question for you. How do you manage what you don't know? When you're scanning a historical building, you can get easily the geometry. But what do you do to add the rest of the information? Do you trust in historical documents or?
No, we don't trust anything.
Yeah.
Yeah, we only model what we know. So again, in those in the models, in the dialog boxes, again, where the information came from is explicit. And again, if something hasn't been verified, again, by point cloud or by inspection, that's noted in the verification models.
Okay. Bueno, pues creo que tenemos que abandonar la sala a -15 y estamos pasados de tiempo. Así que muchísimas gracias a todos. Thank you very much to you all. Y hasta pronto.